Okay, so let's cover your second assignment, and this is really good for anybody who's ever doing an independent samples t-test. As you know, you have to download the My First data set. Now I'm going to show you how to do this, but not using the My First data set. So you need to download that. You need to download this SPSS assignment 2 document. And if you need to, you can download the codebook as well. The codebook explains to you what all the variables are, so you can actually link the name that I have here. Like I have you need to conduct the independent sample t-test for body mass index, self-esteem, and perceived physical appearance, comparing males to females. So the code sheet will tell you everything you need to know to identify the variables. This is the worksheet you have to complete. You'll notice that you have to complete the number and the percent of males and females in the data set, as well as the means and standard deviations for each of these 3 variables divided into males and females, and then you have to provide a write-up of the results. And if you look at the assignment itself, you'll see what I want from the write-up. The write-up should look like this. Of course, you're going to change it because you don't have the variable depressive symptoms there. You're going to modify it to be the variables you need, like self-esteem, perceived physical appearance, right? So you need those variables, and then of course put the correct degrees of freedom. This is the degrees of freedom. This is the Welch's degrees of freedom. Either you're going to use that or you're not going to use the Welch's, depending on whether the variances are assumed to be equal or not. Your p-value, your t-value, your means and standard deviations for each variable. So you just need to replace what I have here with your appropriate content. Failure to do that will result in a loss of points. So if I see depressive symptoms here, you're going to lose points. Okay. So let's go ahead and do this. We need to do a couple things. One is to just get the overall frequency distribution for sex. So let's go into our data set. And our data set has 2 variables, has sex and weight in it. And you can see sex in this case is 1 is female and 2 is male. So that's our coding for that nominal variable. And then weight is in kilograms. And it's a scale, also known as continuous variable. Okay, so since there's only 2 variables here, we can use the dropdown to conduct the analysis. So let's start by doing descriptive statistics. So we need frequencies for sex. So we just reset this. So I'll put biological sex. You could drag it in here. And that's all we need is frequency. So we can hit OK. We don't really need a lot of other stuff. And if you look, you will see that we have a frequency distribution here, right? You have 12 females and 18 males, and here's the percent. Now, in this case, percent and valid percent are equal because there are no missing data. But if you had missing data, you'd have differences. So always use a valid percent, because unless somebody asks you about missing data, that's normally not our concern. To make the comparison between males and females, there's 2 different ways you can do it. One is just to do it through the analysis. When we do a t-test, you will get means and standard deviations for each sex. You'll just get that. But I'll just show you how to split the file, because this is in itself very instructive. So if I want to split this file so I can compare males to females, what I'll do is I'll go under data. So you see I click data, and then I went to split file, and we reset this. Its default is to analyze all cases together. So all the cases are together, there's no splitting. However, you can either set it up so you can compare groups or organize groups by output. When I'm doing something where I need to see what I'm doing in order to write up a report, I like having compare groups. Some people like to organize groups. Like, for instance, you get data first for males and then data for females. So that's up to you. It's your choice. I'll do compare groups. And I'll take my grouping variable, in this case, it's sex. In this data set, sex is set up to be 1 and 2. So as you'll see later, that's not a big deal. It's actually not a big deal here at all. It's just saying let's split the file by sex. It could already be sorted, or I can ask the system to sort the data by the grouping variable. So let's do that. I mean, I'm not even sure if, well, I doubt the data are sorted by sex. So we should allow it to sort the data by sex. So it'll have what I mean by sort. So you'll have 1 and then 2, so male and then female, or whatever the coding is. Hit OK. So now we have our data. And by the way, here's the syntax for how to do this. If you want to add it to your syntax file, I always like to add stuff to my syntax file so I can save it. All right, so we're all set now, right? Now we can rerun. Well, actually, we have to run our descriptive statistics in order to get our means and standard deviations. So we go to Analyze. In this case, under descriptives, we'll hit descriptives because we just need means and standard deviations. And I'm going to reset that since I was practicing. We'll put weight in kilograms here and hit OK. And what I'll get is this really nice breakdown. So I get females and males. So this is designed so I can make a direct comparison. You get the mean and standard deviation for each sex. So you can use that to fill in the tables you need for your assignment. However, as I mentioned, this will be done anyway in this specific analysis. That's not always the case, but just you need to know how to split anyway. So I need to unsplit the data before I run the analysis. So I'll go back to the data tab and look for split file. And now you see it's set to compare groups. So I want to instead analyze all cases together. So I'm going to go back and click that and hit OK. So now I'm set up to run my analysis. And notice it says here split file off. That's your syntax for splitting for ending the split file. So let's go ahead now and run our analysis. So what we want to do is run an independent samples t-test. So an independent sample t-test will compare 2 separate groups, and we're comparing males to females. So they're separate individuals. So we go under Analyze and we go to Compare Means. And we have a variety of options. And in this case, we use the independent samples t-test. So I reset that again. And our variable of interest or test variable is weight in kilograms. In your case, for this assignment, you have 3 variables you plug in there. My grouping variable is biological sex. I put that in here. And in this case, the variables are coded 1 and 2, but you need to check the coding because if you have 0 and 1, this will not work. It'll give you an error. Okay, so make sure you have the right coding to place in here. Hit continue. Look at my options. We're doing a 90. I'm doing in this case a 95% confidence interval because I'm setting my alpha at 0.05. Remember, confidence and alpha are complementary. So I'll just use 0.95. If you wanted a 90% confidence interval, you put 90 in there. If you wanted a 99, you put 99 in there. I hit continue and hit OK. So here's my analysis. Here are my analyses, the results of my analysis. First step, as I mentioned earlier, you get the means and standard deviations for the comparison groups. So if you don't want to split the file, you can just run the analysis and you're okay. And you'll get the data that you need. Okay, first step we have to do is look for equality, whether we have equality of variance. So we only focus on this part of the output first. We're making our comparison. What SPSS is asking us is whether or not we can assume that we have equality of variance. So there's our null hypothesis for Levene's test for equality of variance is that the variances are equal. Our alternative hypothesis is that they're not equal. Okay, so the first step is to test that. This uses an F statistic. We're not going to worry about that now. We'll talk about that next week. So this, but it's like your regular test statistic. It comes with a probability value. Our probability value here is 0.026. If our alpha set at 0.05, since 0.026 is less than 0.05, we would reject our null hypothesis. Therefore, we cannot assume equality of variance. So the second step is to look at the 2 rows and pick which one applies. This one says equal variance is assumed. Well, we cannot do that because we just mentioned that. The second row says equal variance is not assumed, so we'll use that one. Okay, so now we move to this row. We ignore the first row. We move away from the Levene's test to the t-test. So we look at our t-test result. Our t-test result is minus 1.908. So it's clearly it was females minus males, because you got a negative value. Okay, minus 1.908. Again, for us, it doesn't really matter. We look at essentially at the absolute value of that when we compare it to our critical value. But for your case, when you're writing it down, you have to write it as negative in this case, right? Because honestly, it doesn't matter, but just write it down as negative. It doesn't really matter if you say, because if you think about the equation, it's whatever you decide to put first, okay? So I'm okay if you write negative or positive, as long as we know that that's what the difference is. The degrees of freedom, because we could not assume equality of variance, these are the Welch's degrees of freedom. If we did a two-tailed test, right, if we're just comparing males and females, we're not really sure. And in this case, I would say you probably would do a two-tailed test, right? Unless you can provide rationale for why you would have done a one-tailed test. We look at the two-tailed p-value. By the way, sig in SPSS language is p-value, as is p-value. So the two-sided p-value here is 0.069. Since 0.069 is greater than 0.05, if we chose alpha of 0.05, we would fail to reject the null hypothesis, right? So there is no statistically significant difference between the two groups. This is the mean difference, right? So it's 60.10 minus 73.48. We get this value. This is our confidence interval, right? So as you know, it's the confidence. In this case, a mean difference of 0 is what we're assuming the population value to be. So that's what our null hypothesis assumes. So as you know, this confidence interval, it crosses over 0. So that's another indicator that we don't have a significant result. Okay, so let's see what else. So that's pretty much all you need in order to complete the assignment. Here's just a little bit of additional information. We also get these effect size estimates. So these days, in most journals, when you try to submit a manuscript for review, your reviewers will want to have two things. They'll want to have a confidence interval, and they'll want an effect size. Effect sizes in some cases are easier than others to get, and SPSS provides them. Other times you have to calculate them by hand, but here it's provided. You get what's called Cohen's D. So Cohen's D is a very popular effect size. It looks at a standardized difference between the means of the groups, and it has these heuristics. 0.2 to 0.5 is considered small, 0.5 to 0.8 is considered medium, and 0.8 and above is considered large. So we can actually use this. We look at the absolute values to gauge what our effect is. Cohen's D uses something called a pooled variance, and you'll notice that these other ones use different types of variances. But Cohen's D uses a pooled variance. That's actually the same variance that you would use if you were calculating this equation here, and that would be part of your standard error estimate. So this value is 0.609, negative 0.609. So if you took the absolute value, it's 0.609. So we'd consider this a medium effect. So it's interesting that you have a medium effect and you have a non-significant result. So that's interesting because it just tells you what the importance of sample size is. We have a relatively small sample size. If we had a larger sample size, like if we had 100 individuals, this surely would be statistically significant, because larger the sample size, the greater the power, the more likely you are to reject the null hypothesis. So that's just something that's interesting. And there's other effect sizes here, but they're based on using different standard deviations. This hedges use some kind of a correction factor. So you can, if you're interested in that, you can take a look at that. But that's all we had to do, and I'm thankful for your watching this video. Thank you very much. Bye.